So we've got RT, or R1 times T1 equals R2 times T2. So write that down. And then T1 plus T2 equals 60. R1 equals 3. R2 equals 6. Okay, so this first equation that has all the variables, that's the one we're actually going to substitute in for. So this guy right here is what we're going to plug in. So I'm going to replace R1 with what, you guys? With 3. Good. Now, you can choose T1 or T2 to solve for. It does not matter, but you need to pick one. So I'm going to solve for T1. So I'm going to subtract T2 from both sides. So in my middle equation here, T1 is equal to 60 minus T2. All right? So the second equation, you got to solve for one of the variables. Now I have T1, so I replaced R1 with 3. I'm going to replace T1 with what T1 equals, which is this whole thing now, and you have to put it in parentheses. Then I have equals, okay, R2. What should I plug in for R2? Good. So R2 is 6, so we're going to plug that in. And then I have T2. Don't plug anything in for T2. That's the variable we're going to solve for, since I now have T1 in terms of T2. All right. So now we're going to solve this equation. I have to distribute the 3. So 3 times 60 is 180. 3 times negative 2t is negative 3 T2 equals 6 T2. Okay. Get all your T2s on one side, so I distributed. Now I'm going to get all my variables together here. So I'm going to add 3 T2 to both sides. So I have 180 left on the left-hand side, and on the right we have 9 T2. Divide both sides by 9, and we get 20 for T2. It says solve for all unknowns. They gave us R1, they gave us R2. What's the other variable that is unknown? Yeah, T1. So you can come back up here. T1 is equal to 60 minus T2. If I plug in T2 is 20, then what do we get for T1? Yep, so T1 is equal to 40. All right, so that's just more substitution. We've pretty much done that, right? All right, let's try another one. So I have RO, TO equals RS, TS plus 16. Okay, my second equation is RO plus RS equals negative 1. And then they're telling us what TO and TS are. So go ahead and write all those down. All right, so on the second equation, you need to pick one of these to solve for. Doesn't matter which one. So Evan, if you want to solve for one of these, what step would you do? Which variable you want to move to the other side? RO, RS? RO, okay, it doesn't matter. So let's say we subtract RO from both sides. Now I know that RS is going to be equal to negative 1 minus RO. Okay, so now let's substitute some stuff in. So we start with RO. Should we plug anything in for RO, you guys? No, because that's what we're going to solve for. So I rewrite RO. Now I have TO. Caleb, what should I plug in for TO? 8. Good. Equals. Now I have RS. Jackie, what should I plug in for RS? Good. Negative 1 minus RO. Close parentheses. Now I have TS. So, Sophie, what should I plug in for TS? Good. 4. And then I have a plus 16. All right. Let's start simplifying. So these kind of go go together, you guys, normally we put the number in front of the variable, so I'm going to rewrite that as 8RO. On this side, you have to distribute before you do anything else. Multiplication comes before addition, so be sure you distribute that 4. Josh, what do I get if I distribute the 4 here? Good. Okay, and then we have plus 16. Nico, what should we do next? Okay, we're going to add 4RO, so we can get all of our ROs together. So I have 12RO. On the right-hand side, let's go ahead and add my numbers together. I have -4 plus 16. That gives me 12. So, Drew, what's RO equal to? Yep. So RO is equal to 1. Have we solved for all of our variables? Are we done? No. So, Alex, what is our S equal to? Yeah, we replace this with a 1. I have a -1 minus the 1 that we plugged in gives me -2. Now we found all the unknowns. All right, so now we're done. All right, let's try the vertical line test. So this is another way to determine if something is a function. We learned last time that you can only plug in one number and get one thing out, right? So we had a problem if we had something like this, 1, 1, 1, 2, right? If we had 1, 1, 1, 2, what did we say? Not a function, right? We plugged in one number for x, and we got two different y's out. So same thing here, but now we're going to look at the graph, all right? So a graph shows a function if any vertical line you might choose intersects the graph in at most one point. So I want you guys to write down that definition. So these problems make the most sense when we actually look at something that's not a function. So draw a circle, okay? And then draw a vertical line. That means a straight up and down line. So see that green dotted line right there? How many times does that line cross the graph? Twice. That means I plugged in -2 and I got 2. I plugged in -2 and I got -2. So is this a function? No. So if it crosses more than once, it's not a function. All right, so easiest to figure out when you look at the graph. To be or not to be a function, that is the question. What do you guys think? So let's figure it out. The first one. So if I draw a vertical line, that wasn't a very good vertical line, but a straight up and down vertical line, how many times does it cross the graph right here? Once. Okay. What if I draw that vertical line right here? How many times does it cross? Once. So no matter where I draw the vertical line, it crosses one time. So is it a function? Yes. All right, we've got this lovely heart-shaped graph. Let's say I draw a vertical line. I'll get a really straight one for this. How many times is it going to cross the heart here? Twice. So is it a function? No. Okay, that's all we're doing here. How about this graph? We've got a sideways parabola right here. If I draw a vertical line, whoops, okay, how many times does it cross? Twice. Is it a function? No. How about this one? If I draw a vertical line, how many times does it cross? Once. What if I draw it over here? Once. So is it a function? Yes. Okay, if it crosses one time, then it is a function. Let's try it on the whiteboard.